Hey everyone, in this video we will solve the problem squares of a sorted array. You are given a sorted array that may contain negative numbers. Your task is to return a new array containing the squares of each number, also sorted. This looks simple at first, but there is a small twist. If we square every number, will the array still stay sorted? Let's think. So here is the problem statement. We are given a sorted array of integers. The array can contain negative numbers. The task is to return a new array containing the square of each number, and the result must also be sorted. The sorted part is important. We will use it later. The first idea is straightforward. We square every element. Then we sort the array again. This gives the correct answer. Here, the time complexity we find is O(n) log n since we are sorting the array again. But notice what's happening here. The input array was already sorted. After squaring, we lost the order, so we are sorting again. That extra sorting costs n log n time. This is the work we want to avoid. Now let's look at the array again. After squaring, negative numbers become positive. So the largest square does not come from the middle. It always comes from one of the ends. That observation tells us how to proceed. We only need to compare the two ends of the array, and we will build a new result array as we go. So these are the steps we will follow. Compare the absolute values at left and right. Place the larger square at the end. Move the pointer you used and stop when left crosses right. Here the left pointer is at -4 and the right pointer is at 10. We compare the absolute values 4 and 10. 10 is larger, so the right value wins this comparison. We square 10 and place 100 at the last position of the result array. Because we used the right value, the right pointer moves one step left. This completes the first comparison. Now the left pointer is at -4 and the right pointer is at 3. We compare absolute values 4 and 3. 4 is larger, so we square -4 and place 16 in the next position from the back. Because we used the left value, the left pointer moves right. Now the left pointer is at -1 and the right pointer is at 3. We compare absolute values 1 and 3. 3 is larger, so we square 3 and place 9 in the result array. Because we used the right value, the right pointer moves left. Now the left pointer is at -1 and the right pointer is at 0. We compare absolute values 1 and 0. 1 is larger, so we square -1 and place 1 in the result array. The left pointer moves right. Now both pointers point to 0. We square 0 and place it in the last remaining position. All elements are now processed. The final sorted squares array is 0, 1, 9, 16 and 100. Let's quickly check edge cases. If all numbers are negative, the same logic still works. If all numbers are positive, the array stays in order. If there is only one element, we square it and we are done. Zeros in between also don't change anything. No special handling is required. Let's summarize the algorithm. We use two pointers, one at the start and one at the end. At each step, we compare the two ends. We place the larger square at the back of the result array. Then we move the pointer that we just used. We repeat this until all elements are placed. Now that the algorithm is clear, let's translate this into code. Let's go through the problem statement and solve it in LeetCode. Given an integer array nums sorted in non-decreasing order, return an array of the squares of each number sorted in non-decreasing order. So the output should be in non-decreasing order as well, as we discussed. This is LeetCode 977 easy problem. Here the nums is -4, -1, 0, 3, 10 and output is sorted 0, 1, 9, 16, 100. Another input -7, -3, 2, 3, 11 and output is 4, 9, 9, 49, 121. Here are the constraints. Here nums length should be greater than equal to 1 and less than equal to 10 to the power 4. This basically means the array length can go up to 10,000. So we need a solution that runs in linear time. Next constraint, nums I, that means each element can be between -10 to the power 4 to 10 to the power 4. That basically means each number can range from -10,000 to +10,000, which means negative values are allowed. And most importantly, the input array is already sorted in non-decreasing order. Now let's go through the steps. So as this is a two-pointer solution which we discussed earlier, we will use one pointer at the start of the array and one pointer at the end. So here n is length of nums. We will create a result array of the same size. Since the largest square comes first, we will fill the result array from the back. This creates a final array with same number of length as nums with all elements as 0. This is basically initializing a resultant array. Now we will create both pointers, left and right. Left pointer starts at the beginning and right pointer starts at the end. We will create another pointer. This is basically not a pointer, rather than it's an index where we place the next value in the final array. So position should be n-1 because we will put the largest element from the end of the array. We keep looping until the left pointer crosses the right pointer. At each step, we will look at the values at both ends. We will compare their absolute values because squaring removes the sign. So first get the elements. Nums left will be nums at left index, nums right will be nums at right index. Now compare the absolute values between both. If the left value has a larger absolute value, we square it and place it at the current position in the result array. And we will move the left pointer to the right. That means incrementing by 1. Else, that means if nums right is greater, then in that case we square the right value and place it in the result array. Then we will move the right pointer to the left. That means decrementing the right value by 1. Now after we place the value, we will move the position index one step backward since we are starting from the end. We will repeat this process till all elements are placed. Now we will just return the final result. The result array is now filled in sorted order, and that's how this works in linear time. Let's run the code. It ran successfully. Let's submit it. It submitted successfully as well. So we use two pointers to choose values and one index to place results from the back. So that's the complete implementation. Now let's step back and summarize what we did. So to summarize the solution, we used two pointers instead of sorting again. At each step, we compared the two ends and placed the larger square at the back. That's how we achieved a linear time solution. We have now written the full solution. Pause the video here and try implementing it yourself. This is the most important step. Now that we have written the code, let's step back and analyze it. Notice that we process each element only once, so the time complexity is O of n. We do use an extra array to store the result. That's why the space complexity is also O of n. Let's pause and reflect on what we actually learned. First, why squaring a sorted array breaks the order. Second, how comparing only the two ends fixes that problem. And most importantly, how to think in patterns instead of memorizing code. In the next video, we will solve another problem using the same two-pointer pattern. Different problem, same way of thinking. That's it for this problem. If this explanation helped you, please like, share and subscribe to Tech Trouble Solved. Thanks for watching and I will see you in the next video.